From our vantage point on Earth, the night sky is a familiar and cherished spectacle, a serene canopy of tiny lights that seem to dance and shimmer. We write poems about twinkling stars we wish upon them. We chart our courses by their familiar patterns, but leave our planet's protective blanket of air, and that entire celestial picture transforms dramatically. For an astronaut floating in the silent vacuum of space, the stars do not twinkle. They are not soft, flickering points. Instead, they appear as intensely sharp, hard, and unwavering diamonds pinned against a backdrop of the deepest, most profound blackness imaginable. The sky is no longer a gentle dome above us. It becomes an immense, crystal-clear void filled with a silent, steady fire. The difference is not just a minor detail. It is a fundamental shift in perception that redefines one of the most universal human experiences. The twinkle of a star is a lie, but it is a beautiful and local lie told by our own atmosphere. To understand why stars do not twinkle in space, you must first understand why they do on Earth. The light from a star is a single, tiny point of light traveling across immense distances. Before it reaches your eyes on the ground, it must pass through Earth's atmosphere, a turbulent and ever-shifting ocean of air. This air is not uniform. It consists of countless small pockets of varying temperatures and densities. Each pocket acts like a tiny, weak lens, bending the starlight slightly. This random bending is atmospheric scintillation. As the pockets move and churn, the starlight is deflected back and forth. For a fraction of a second, the light is bent away and the star dims. In the next moment, it can be bent toward you and brighten. Those rapid fluctuations in brightness and position, we call it a twinkle. It's not the star changing. The atmosphere is playing tricks. Planets, being much closer, appear as tiny disks, not points of light, so distortion averages out across their surface. They usually don't twinkle. Now imagine you're in orbit, hundreds of miles up. You are in a vacuum. There is no air, no atmospheric turbulence, no pockets of warm or cool gas to bend the light. Starlight travels straight to your eyes, uninterrupted. One of the most immediate and overwhelming impressions for anyone looking at the night sky from orbit is the sheer, unbelievable number of stars. Here on Earth, even on the clearest, darkest night, far from city lights, a person with good eyesight can see perhaps 2,000 to 3,000 individual stars. This view, which we consider breathtaking, is just a tiny fraction of what is truly out there. Our atmosphere, even at its most transparent, scatters a faint amount of light and contains microscopic dust and water vapor that create a subtle haze, obscuring the faintest stars from our view. It's like looking at the sky through a slightly foggy window. You see the brightest lights, but the subtler details are lost. When you move above that atmospheric fog, the window is thrown wide open. In the perfect clarity of space, the number of visible stars explodes. Faint stars that were completely invisible from the ground now pop into view, and the spaces between the familiar bright stars become filled with countless new, dimmer points of light. Just as the atmosphere obscures the number of stars, it also subtly alters their apparent brightness and color. The same scattering effect that makes the sky blue during the day also has a minor impact at night, dimming starlight and scattering some of its colors. In the vacuum of space, this filter is removed. Stars appear noticeably brighter, and their colors, though subtle, are more distinct. The light is crisper and more intense, having traveled unimpeded across the vastness of space. This is why space-based observatories like the Hubble Space Telescope can capture such exquisitely sharp images. They are operating above the blurring and dimming effects of our air. Beyond the individual points of starlight, the view from orbit reveals the grand structure of our cosmos in breathtaking detail. Chief among these sights is our own galaxy, the Milky Way. From a dark location on Earth, the Milky Way appears as a faint, milky band of light stretching across the sky, its details obscured by atmospheric haze. From the International Space Station, this faint band is transformed into a magnificent, luminous river of light, teeming with structure and depth. It is not a flat ribbon. It appears intensely three-dimensional, a sprawling, glowing entity that you feel part of. Astronauts consistently describe the Milky Way from space as one of the most stunning and unforgettable sights. The bright, bulging central core glows with the combined light of billions of ancient stars. Running through this river of light are the great dark rifts, immense clouds of interstellar dust that block the light from the stars behind them. From Earth, these dust lanes are subtle. From space, they are stark and well-defined, appearing as deep, black chasms cutting through the stellar glow. This contrast gives the galaxy texture and form impossible to appreciate from the ground. The view is not limited to our own galaxy. On a clear, dark pass, an astronaut's naked eye can pick out our closest galactic neighbors. The Andromeda Galaxy, over 2.5 million light-years away, appears as a small, faint, fuzzy oval of light. While it doesn't resolve into individual stars, its presence reminds you you're seeing an entire island of hundreds of billions of stars, a tiny smudge from so far away. While the view of the stars from space is unparalleled, actually seeing it is not always easy. Stargazing from the ISS presents a unique set of practical challenges. The most significant issue is light pollution, not from cities, but from the sun and the station itself. The ISS orbits Earth every 90 minutes, meaning it experiences a sunrise and a sunset about 16 times a day. The night portion of each orbit, when the station is in Earth's shadow, lasts only about 45 minutes. This is barely enough time for an astronaut's eyes to become fully dark adapted, a process that can take 30 minutes or more. Any stray light from inside the station, like a glowing monitor or an interior light, can ruin that night vision instantly. Furthermore, the sun's light is incredibly intense in space. When the station is on the sunlit side of Earth, the glare reflecting off the planet's surface or the station's own white structures can be completely overwhelming. To see the stars, astronauts must wait for orbital night, turn off all the lights in their module, and look out from a dark window. Yet, when they do, the experience is often transformative. This profound cognitive shift in awareness is known as the overview effect. Seeing the Earth as a fragile blue marble suspended in the vastness of space, with the unblinking stars as a backdrop, has a deep and lasting psychological impact. Borders vanish, and the planet appears as a single, interconnected system. Apollo astronaut Edgar Mitchell described it as an explosion of awareness, a feeling of deep connection to the planet and all of humanity. Many astronauts return with a newfound sense of responsibility to protect our world, a feeling born from seeing its beauty and fragility from a distance. This powerful combination of seeing the endless steady stars and the small vibrant Earth is perhaps the most important truth astronauts bring back. It is a dual perspective, one looking out into the infinite and one looking back at our finite home. The challenges of stargazing from orbit only make the moments of clear viewing more precious. The view reminds us that we are inhabitants of a tiny, precious world in a vast and ancient cosmos. Seeing the stars without their twinkle does not diminish their magic. It deepens it, revealing a universe of staggering scale and clarity.